Okay, so today we're going to be solving equations, and everything that you need to know for solving equations, I've already taught you. We're just going to like put together thoughts of different things we've already learned in here. So the first question is 100 to the x equals 1/10 to the x minus 30. And when I look at 100 and I look at 1/10, I feel like both of them could be written as a base, the same base, to an exponent. Do you know what base gives me 100 and what base gives me 1/10? Different exponents, but you know what base I'm looking for? Not hard. It's 10, yeah, it's 10. So 10 to the what gives me 100? 10 to the second, and then there is an x up there, so that stays up there, equals 10 to the what gives me 1/10? -1. And then we still have that x minus 3 up there. But since I have an x minus 3, that's two terms, when I multiply these together, I will be distributing them. So now, when I solve equations, I try to get x by itself. And the last thing that's being done to the x, the furthest thing away from the x is that big old 10. How do I cancel out a base of 10? What is the inverse operation of base of 10? Log, which base? Base 10. Which is our common logarithm, and we don't have to write the base, but I'll write it just for this first one. Maybe. My pen thing will, I don't know where to go. Oh, come on. I don't know. Okay, you didn't have to write the little 10 because if we just write log, it means log base 10. But I wrote it just for this first example because log base 10 and a base of 10 are inverses and they undo each other. Log base 10 and a base of 10 are inverses, they undo each other. So now my next step looks like this. 2x equals negative x plus 3. Can you solve it? I hope so. Add x to both sides and divide by 3. We get x equals 1. To know that you were right, you would, type that back in or check it, plug it back in. But we don't have a lot of time for checking today, so I'm just going to move on to the next one. So my next question, can I take a base of 2 and a base of 7 and make them into the same base? I can't. So I'm going to have to do what is new today. This is like the only thing new. It's not even that new, but it's new. If I have an equation, if I want to do something to 2x, what makes it okay if I do something to 2x? If I have an equation, as long as I do the same thing to the other side and do whatever I want. So I'm going to do log base 10 to the 2x. And as long as I do log base 10 to 7, I'm allowed to do it. The reason why I did that, watch this. Using what you just did for your homework, that x is an exponent. I'm going to use that property that says if it's an exponent, where can I put it instead? Right in front. So now I have x multiplied by log 2 equals log 7. And what are we trying to get by itself? What are we trying to get by itself? What are we trying to get by itself? X. So right now, X is being multiplied by log 2. How do I cancel out multiplication by anything? Divide by whatever that thing is. So I'm going to divide both sides by log 2. And since it's being multiplied, I can divide by it, and I get X by itself. All right, so at this point, I have X by itself. All I have to know is what is log 7 divided by log 2. And the reason why, when we first did that very first step, why I chose log, is because that button is on my calculator. So now I can just type in log 7 divided by log 2, and I have an answer. That's why I chose log in the first place, because that one I can do on my calculator. So go ahead and find that answer. It's going to be a decimal. Do it to 3 decimal places. I'll put the answer up so you can check. What do we get? Approximately, what'd you get, Bert? 801? Yeah. Okay. We don't have time to do all of these. This is a good number 3. I will have all of them posted. So if you see one in homework that looks like number 1 and you don't know how to do it, I'll have all the answers posted. But number 3, let's go over that one. Might have time for number 2, we'll see. Okay, so number 3, what would you do first to solve for X? You're going to have to participate. What would you do first to solve for X? This one. What do you think? Okay. The exponent? Is that what you're saying? Well, you're saying put it up. Yeah, that's not right. Okay. Not going to work because that only works with logarithms. And I don't see a word log over there. What do you think? Yeah, just add that 7 to the other side. That's right now we have something subtracted 7. So if we add the 7, now we have that something equals 20. We're trying to get to E. We're trying to like break away the layers one at a time until you can get not to E to the X. To get to the X. So what's the next layer I need to get rid of? The 4. How do I get rid of something that's being multiplied by 4? Divide by 4. So we have E to the negative 0.3x equals 20 divided by 4 is 5. So I'm peeling away the layers until I can get to the x. What's the next thing I have to get to? Or get rid of? How do you get rid of E? ln. We've already learned that. So to both sides, ln e to negative 0.3x equals ln 5. That ln and the e are inverses. They cancel out. We get negative 0.3x equals ln 5. Still peeling away the layers until we just have x. What can I get rid of next? Divide both sides by negative 0.3. So I'll have x equals, now ln is a calculator button, so type into your calculator ln 5 divided by negative 0.3. And type it in so you can make sure that you are typing it in correctly. I'll put the answer up. Just solving equations. You're peeling away those layers. You just have to do the inverse operation each time. I know some of you really need to work on solving equations. Yeah. Okay, if we have time, I'll go back and do 2, but we'll see. Okay, the next one is, again, solving a word problem. It's solving a problem just like we did. You're just going to have to plug this stuff into the equations they gave you. And I know I had a lot of people last year had trouble with this because it involved knowing what these are, because it says it in the paragraph. You have to read it. So I'll go through it with you. T is the temperature. Oh, I'm sorry. This is a cooling rate. So if I take something hot and I put it in a room that is not that hot, it's going to cool down. It'll cool down until it reaches what temperature? Room temperature. It's not going to get colder than room temperature. It'll stay the same as room temperature. So there's a rate at which different masses cool. So this is about a stew. So they give you this cooling rate for the stew. To find this cooling rate, you have to have more information. But to find the cooling rate, we'll do that a different day. But you need to know the cooling rate. You need to know the temperature that it came out of the oven or came off the stove at. So this is telling you the temperature that we are starting at, 212 degrees Fahrenheit. Up here, the temperature it's starting at is T sub 0. That's the initial temperature. And then T sub R, which there's 2 of them, is the room temperature. So you would need to know the room temperature. So the little tiny r up in the exponent is the cooling rate. And then T up in the exponent is how many minutes it cools to give you this new temperature. So we plug everything into this formula using this stew that you're cooking. Alicia? Yeah. You want to serve the stew at 100 degrees Fahrenheit. So that's going to be the temperature we want it to be. It starts at initial temperature of 212, and we subtract off the room temperature of 70. Multiply that by e to the negative, and then we do our rate, which they gave you, 0.046, multiplied by time, but that's what I'm trying to solve for. I don't know time. And then plus room temperature. Now, we are going to be peeling away the layers until we can get to T. What do I need to do first? Solving an equation. What should we do? Aiden? Which 7? I'm going to do what's inside the parentheses first. That says 212 minus 70. Solve 100 equals 142 e to the negative 0.046 t plus 70. We got rid of parentheses. Now we are getting rid of what next? The other 70. You're going to subtract it from both sides. So now we have 30 equals 142 e to the negative 0.046 t. We're peeling away those layers until we can get to the t. What do we get to do next? It's just solving the equation. Jessica, do you know what I do next? Okay, I'm going to divide both sides by 142. And I'm actually not going to type that in my calculator yet. I'll do it later. Because I bet that's not a nice answer. Maybe it is, but I don't think it's a nice answer. Just going to leave it. What's the next thing we need to get rid of? How do I get rid of these? ln. So we're going to do ln of 30 over 142 equals ln of e to the negative 0.046 t. So that cancels out ln and e. So ln 30 over 142 equals negative 0.046 t. Almost there. What do I do now? Let's get t by itself. What do we do? Second, what do we do?
Divide negative 0.046.
Both sides?
Yes.
Divide both sides by negative 0.046. And we will get t by itself. So go ahead and type that into your calculator. It will be an approximate answer. Maybe, if you plan on being a chef someday, you might need to understand this cooling rate formula so that you don't burn somebody's mouth or get somebody sick. You can stand. Not gonna block anybody. These next few lessons you don't want to be sleeping through because you've never seen it before. Are we good? All right, just a couple more examples. These are still solving, but these are going to have just a couple extra steps to them. So example 3, I'm just going to rewrite it because there's like an A and a B right there. I've got ln 4x minus 7 equals ln x plus 5. We have to solve for x. You're going to peel away those layers. What's the first thing I need to get rid of? What do I need to get rid of? I am solving for x. I need to get rid of ln first. And what is the inverse of ln? E. But e is always has an exponent. So when you put that e in, this entire side of the equation becomes the exponent. Put the e in, the entire side becomes the exponent. It's called exponentiating. So then the e and the ln cancel right away. And we have 4x minus 7 equals x plus 5. And then it's like 8th grade math or algebra 1 at that point. Solving for x, subtracting x from both sides, adding 7 divided by 3. X is 4. How would you know if you did it right? You could check your answer, plugging it into the original one, and it'll come out nice. It'll check very nicely. All right, the other question is, we've got log base 2 of 5x minus 17 equals 3. So we need to get x by itself. What do we need to get rid of first? How to get to x? What do we need to get rid of first? What's the outside thing we need to get rid of? What? Can't hear you. Oh, log base 2 we have to get rid of. What cancels out log base 2? Base 2. 2 to that. It's the same thing we did here, only it's going to be a 2 to the, instead of an e to the, same thing. So we're going to do 2 to the, this entire side becomes an exponent. Log base 2, 5x minus 17 equals 2 to the third. And you should know 2 to the third is 8. And 2 to the log base 2 are inverses. They cancel out. So we get 5x minus 17 equals 8. And then you can solve that really easily. 5x equals 25, so x is 5. Yay. I'm not sure 100% because I don't know exactly what they're going to put on the ACT tomorrow, but I know that logarithms have been on the ACT tests in the past. So maybe something we do today will help you tomorrow. Or in the future if you're not taking it. Okay, example 4. We now have log 2x plus log x minus 5 equals 2. When you have multiple terms like this, when you have multiple logarithms, the first thing you have to do is you have to condense it to one logarithm. You cannot have log of this plus log of that. It has to be condensed, which we did in our assignment, and almost every single person has their assignment in here. So you all should know how to do it. Unless you copied your homework. Then you're just hurting yourself in the long run. So when I condense, what does addition mean? It means we multiply. We write one logarithm, and then you multiply together 2x times x minus 5. There's no logarithm on the other side, so I just leave it as 2. Once I have condensed it down and we just have one logarithm, now I can cancel it. So what cancels out log? What's the base of log? 10. So what cancels out log? 10 to the. You're going to exponentiate. You're going to do 10 to the, and then in the exponent you write log 2x times x minus 5. And to the other side, 10 to the 2. We exponentiated. That will cancel out 10 and log. So we will get 2x multiplied by x minus 5 equals 100. Next thing I'm going to do is I'm going to distribute that 2x. Get rid of those parentheses. So now I have 2x squared minus 10x equals 100. We just solve for x. Oh, how do you solve for x when you have x squared? You got to set it equal to 0 before you start factor. You got to set it equal to 0. And then maybe we can factor. Are there any other methods besides factoring? Quadratic formula, right? You can sing the song. You can do complete the square if you remember it. It's been a while. I never practiced it. This one does factor, so we'll go ahead and factor it. First step of factoring is GCF. Is their greatest common factor? Yes, 2. Then we have x squared minus 5x minus 50. Then we're going to factor with guess and check. So this will be x and x. We'll have 1 plus, 1 minus. I'm going to get the minus 10 and the plus 5. Once you have it factored, what do? Set each factor equal to 0. Each factor equal to 0. So we have x plus 5 equals 0. And x minus 10 equals 0. Why don't I set 2 equal to 0? Why don't I set 2 equal to 0? What did you say? Doesn't have a variable. Doesn't have a variable. And 2 doesn't equal 0, ever. So I've got x equals negative 5 and x equals 10. Now, do you remember the term extraneous solutions? Well, I didn't spell it right. I think that's what it is. Extraneous solutions. Do you remember this term? It's like extra solutions. Do you remember this? How do we know if we have an extraneous solution? you have to check your answer. So there will be extraneous solutions. And with logarithms, if you get the log of a negative number, it doesn't work. If you try to do the log on your calculator of a negative number, it won't work. So that's how you can check your answer. If you plug it in and you get log of negative something, that answer doesn't work. So we'll check. Our first one is, what's our first answer? Negative 5. So I have log, I'm going to do 2 times negative 5. I'm going to stop right there. Because when I start to check this and I do 2 times negative 5, what do I get? Log negative 10. What did I just say? You can't do log of a negative number, so negative 5 doesn't work. That one doesn't work. How about 10? We better check both. So log, you do 2 times 10. That one's going to work. Then it was plus log of 10 minus 5. Yep, that one will be fine. So we should be good with that one. You just can't have the log of a negative number. That's how you know it's been checked. Okay, we have like 5 minutes. I'm going to do one more example. Let's do number 7. Let's do 7. Sure. Okay, what would be my first step to solve this? Just like what we did. I have to have one log only. One log. Right now I've got log 5x and I have log of x minus 1. You can't do that. We have to condense it. So I'll have log 5x. What do I do to the x minus 1? When I condense it, it was addition. It's going to be multiplication now. Okay, condensed it. Well, maybe we should have done 8. 8's better. That's all right. What's the next step? What do you say, Nathan?
Oh, cancel out log.
How do we cancel out log?
10 and then everything else down.
Yep. You're going to do the exponentiate by a base of 10. So we get 5x multiplied by x minus 1 equals 100. So we have 5x squared minus 5x equals 100. I'm going to make that equal 0. And you would factor and solve this. I'm going to pause on that one because I'd rather do this, the last one. And write factor and solve. Check. I'll probably do that one and post it so you have the answer if you want to go back and look at it. But let's go over the last one. The last one's the same but a little bit different. Make sure we do that one before we go. So same question. Do we have 2 separate logarithms? Can't. So what should we do? Condense them. So we're going to have log base 4 of x plus 12 multiplied by x equals 30. So now what would be my next step? When you cancel the log, how? 4 to the. We're going to exponentiate with a 4. And then we'll put everything in the exponent. That will cancel out the 4 and the log base 4. I'm going to multiply this out, so we'll get x squared plus 2x equals 64. So it's x squared plus 2x minus 64 equals 0. Does that factor?
Is that 12 not 2?
I'm sorry. I looked at my paper. I didn't pay attention up here, but I looked at my paper. All right, so we got a different. So it's actually 12x. Okay, so different question. Does that factor? That one does factor. I don't think the other one did. That's why I just look at my paper. But that's okay. If it doesn't factor, you could just use the quadratic formula. I hope you remember it. This one does factor, and I'm solving it. And then you need to check to see if we have any extraneous solutions. So when I plug that back in, what happens if I plug in negative 16 into the first parenthesis? And I plug it back into the question, which you can't see if you're looking up here, because it's way up there. What happens if I plug in negative 16? If I do log of negative 16 plus 12, what happens? You get a negative number. 16 can't be an answer. Does 4 work? If I plug in 4 for my x's, will I get a negative? So 4 would be fine. Okay, so on the assignment, it's big ideas. Yep. And then if you can't get on big ideas for some reason, I'll have the assignment written on Canvas for you. You can do it on paper. You're probably going to have questions. I wouldn't even submit it. You're probably going to have questions.
Students, if you are taking the ACT group session,
Remember your calculator tomorrow.
14. ACT go to room 214.
Remember your calculator for tomorrow. As long as you don't have like formulas in there yeah, I didn't think about it. I know I'm going to have a bunch of people coming in here. Oh, you're in. Yep, put your phones away. I mean, they're away. So part of it is calculated, part is not. So I'm going to give you the whole task. Okay. And then, yes, and as soon as you're done with the non part, you turn in and you can take that out. But I'll give you it all because just in case you get stuck on the questions on the non-calculator part, you can just work on the calculator part. You don't have to have a calculator for most of the questions. So if there's a non-calculator section, you know, if you like get stuck and you're not thinking about a lot of something that helps us, you can just go work on it and you just can't think out of the calculator until okay. And then this is for the not recorded population section.
Okay.
So you don't need that for any of those. Okay. Thank you. Yes. Then you can tell me that. Yeah. Yeah, if you need more space, just use what you need. Yeah. Yeah. Just put that on there. Right. Hi.
Could I have a custodian please meet a student at locker bay A? At locker 211. Thank you.
Yeah. And if you don't want to put it in the bucket, just throw wherever you feel comfortable.